So this video is again part two of inverse trig functions, and so what I'm seeing right now is our geography, right? Where to draw the quadrants, or sorry, where to draw the triangles in which quadrants. And so I think I've highlighted the ones I still need to do. So the first one I have is part C, where it says inverse sine of -1, arc sine of -1. So I have to think about the sine function, and I know sine is defined in quadrants 1 and 4. And when sine is negative, it's down in quadrant 4. It's down here. But when there's no hypotenuse, or I mean, like there's no ratio other than like -1 to 1, I've got to realize that that's a quadrantal value. So that's sitting down here because remember, in the unit circle, the sine function follows the y. So here's where y is -1, and so that answer would be -90 degrees, or -pi/2. And remember, there are other angles that might have that ratio, but we want the principal one. Okay. Now going to part F. Arc secant of 2. So again, arc secant, or remember the notation could be like secant inverse, like that. Same thing. A ratio of 2, it's positive, so I know I'm in the first quadrant, and that's a 2-to-1 ratio. So I'm looking for that right there. That's √3, opposite that. So that's a 60-degree angle, or pi/3, depending on, do you have degrees or do you have radians? Okay. Arc cosecant of 1, again, thinking about those values that are 1 for like secant and cosecant and sine and cosine, those are going to be quadrantal values. So since it's positive, we would think up here in quadrant 1, but then we realize there's no triangle possible. So we're again following the reciprocal of the y value. And so that would be equal to 90 degrees, or pi/2. Because again, thinking about how would you draw a triangle whose cosecant ratio, so the hypotenuse over the opposite, is 1-to-1. Well, like you can't have the hypotenuse bigger than, or equal to, I should say, than the leg. That would make that side 0. So then you could think, oh, well, maybe it's like an imaginary triangle. I go 0 in this direction, 0 in that direction. I'm just smack up here in the top, which is exactly where. Right, that's exactly where you'd be if you go 0 in the x direction. Then you're right there at pi/2. Arc sine of 0. Again, thinking about drawing a triangle. Whose sine ratio is 0-to-1. Well, that collapses, right? It completely collapses down here, and so you're sitting right there at 0 degrees, or 0 radians. And again, thinking about why does that happen? Oh yeah, because the y value is 0. So it's 0. So sometimes drawing those imaginary triangles is helpful too. Okay, arc cotangent of -√3. Cotangent, when it's negative, is in quadrant 2. So we were looking for the obtuse angle. And cotangent's ratio is adjacent over opposite. And so then, my missing length is 2, and that's a 30-degree reference angle there, but we want the obtuse angle, so it's 150 degrees, or 5 pi/6. Either one is fine. We did that one. We did J. Now, arc secant for K of -√2, much like arc cotangent, arc secant, or inverse secant, is also defined in quadrant 2. Again, we got to know that geography. And so then this is a ratio of -√2, or like you think of it as -√2/1. So a hypotenuse is never negative. So there's your -√2/1 ratio. Opposite side is 1. So that's another 45, 90 triangle. 45 degrees is the reference angle, but we want the obtuse angle of 135 degrees, or 3 pi/4. And then the last one here, inverse sine, or arc sine of -√2/2. So this time arc sine, or inverse sine, being negative. So that will sit me down here in quadrant 4. And, this -√2 to 2, the -√2 to 2, if you do the Pythagorean theorem, you would get this also to be √2. Or maybe you recognize this ratio. Another way to represent that is 1/√2, or -1/√2. That's the same triangle, right? Hopefully you recognize when you have that √2 in there, negative 1 to root 2. Same triangle, that's a 45, 45, 90 triangle. But because we're down in quadrant 4, it's a negative 45 degrees. So we could say negative pi over 4 or negative 45 degrees. Okay, so again, just knowing the geography, you have to know where do you draw those triangles. And without a calculator, they'll all be like multiples of 30, 60, 90, 45, 45, 90, or a quadrantal value where you have to draw and draw and follow on the unit circle of the x or the y component.